See, all this area is given 0.4 right angle. Three 20%. See, 20% of initial value. That means let's take initial value as B. We had two B's, right? So B1 as initial value and B2 means 20%. This is 100%. So it is 100%. So it will be 1. This will be 0.2 for B1.
Sir, how 0.2?
Divide by 100. 20% divide by 100.
The answer is 0.4.
This is not answer actually.
Sir, the total amount.
Okay, answer
After
is
reducing.
4.
0.4.
It is option C you're saying, right?
Yes, sir.
Okay, let me check.
Yes.
Question number 14. B. No, dear, it's not C, it's B.
Yes, sir, 0.4.
Okay, let's check. Okay, this one we did. Then let's go with the formula. Equals to A B1 minus B2 by T. Area is how much? What's the value? 4. Yeah. 4, 1 minus 0.2 divided by, what's the time? What is it? 0.5. This is for B1. So E value is given how much? 0.32. For 0.8 B1 by 5. Fit of this one 5 80 80 16. What it will be? Are we getting option B? Check. (32 into 5) 150 160.16 432 0. No, not 0. 3.2. No?
0.5 only, sir.
3. Oh, it's not writing. Zero point 0.05. 350 means 150 and 210 means 10 plus, so it is 160 means 0.16. So option B. Done, both of you? Abdisha, Pravalika, you got answers right?
Yes, sir.
Yes, sir.
Next is ठीक है. Let's start this self-inductance. Now, self. What do you mean by this self? Itself, right? Self done. Itself, it is doing. It is happening like this thing you have studied in 10th standard too. Or you remember that coil and moving coil and magnet? You both remember? Standard moving coil and magnet, like we'll place a coil and here galvanometer. We'll bring a bar magnet nearby. Then this galvanometer will deflect. If you move back side, it will deflect on other side. If you are not moving, it will not deflect. Do you remember this? Yes or no?
Yes, sir.
That is self-induction. Now, with this, we studied one more thing. What is that? Do you remember that? There was one coil placed here, connected with battery, with more windings.
For self-induction.
There is mutual. And there is a
Winding,
winding.
is it referred to solenoid?
Yeah, it is similar to solenoid. This is galvanometer. And due to this more windings, this will deflect. And if you change polarity from plus to minus plus, this will deflect on other side. If we open this switch and stop the current flowing, this will deflect in opposite direction, but for very few seconds, and slowly, gradually it will reduce to zero. Have you seen galvanometer, right? It at center it will be zero. It will deflect right or left. Do you remember this practical in the 10th standard? Both? Okay, yeah. You studied 10th standard when it was locked down. So I think so you might have not studied this one, deleted portion. It was deleted portion, right, for you? No? Yes? I don't remember. Do you remember or not? I'm asking both of you.
Yes.
Am I audible? I think so.
Yes, sir.
Self-inductance means, let's write first definition. Property of a coil which the coil opposes any change in the strength of current by itself. Inductance. Okay, see, in 1 minute this meeting will be over as per our timing. So see, magnetic field and this direction will be thumb rule. And rule. Right hand thumb rule. Done writing?
Sir, 1 minute.
Yeah. So this meeting will automatically over.
Done. Sir.
ठीक है. See, this direction will be given by right hand thumb rule. So you know right hand thumb rule, right? Thumb shows direction of current and curling finger will show direction of magnetic field. Oh, it didn't go over. Very good. Now, what does this say? Is the self-inductance? It is just a property of coil by virtue of which the coil opposes any change in strength of current. That means whenever there is a flow of current in coil, it will disturb that magnetic field around any coil. See, every coil, when we pass current, it will generate its electric field around it. And when we place a magnet nearby, magnet will have magnetic field. Electric wire will have electric field. So in our earth has gravitational field like that. So this that will be around a magnet, so it will disturb. So that will be generating your that will be inducing your like EMF, induced EMF. So induced EMF means inducing means generating some current supply, voltage supply. That is your induction. That we will use in generator. This relation or this formula, this property we will use in generator. So this by this idea, it was this idea was given by Mr. Fleming. Fleming's rules and Faraday law. So this all laws we are studying all for generator and motor. Okay, so tomorrow we'll have mutual induction. So tomorrow we'll discuss mutual inductance. Okay? Done writing, both of you?
Yes, sir.
Yes, sir.
Okay. Send it out in this one.